built the same so that the dimensions and tolerances are going to give us the strongest frame possible.
Well, what we do is we put the pieces together, we spot weld them, that way they don't move, and after we get them all put in, we go ahead and finish welding the whole thing up. This is oxyacetylene welding. We do this because it normalizes it as we go. That means it's all done naturally with gas instead of quick welding with the Heliar.
When the frame's all welded in the jig, we bring it out, and our QC man comes over, and he's going to inspect every weld. And as he's going through, he will use a yellow marker, and he'll literally outline every weld on the airframe so that we know that it's been inspected 100%.
Finally, all the holes are drilled, so we can now put the airframe, thanks to a bit more help from Dave, onto the landing gear without knocking the landing gear out of level. And it just sits on the rear landing gear like that, and then should drop down. Thanks, Dave. Pull like that. Now, the airframe itself bolts onto the landing gear in 4 places. At the front, the bushings that I had to drill and do the oxyacetylene with, it'll bolt through there. And at the rear, it bolts through this plate here onto this bracket that's welded onto the landing gear itself. It's very important that when this is attached and this bolt is put through this hole and it's all bored out, that these don't make contact, because otherwise that's going to put a major stress line on the landing gear. So this will actually have to sit slightly higher, something like about that. Both sides have got to be drilled through and bolted, but I've got to make absolutely sure that up here, this cross member is completely and utterly level. To do that, use another little gadget, another little inclinometer. This is the baby, and you can see if you plonk that on here like so, the gauge at the front will tell you, okay, that's 0.3 degrees, and the arrow says down there, up there, so I know that to sort it out, this end's got to go up. And that is on 0. Right, that is all clamped up nicely, and there's a lovely even gap all the way around here so that this plate isn't touching the landing gear at all. With that clamped, I can now sort out the fore-aft angle. The tail boom, which attaches to the airframe here, is at an angle to the horizontal. And to set that up properly, we need to make sure that this square section tube here is exactly 4.5 degrees above the horizontal when the whole thing is set up for the tail boom. But because I've taken off these, which are the tail boom support braces, that means this part of the frame has dropped by 0.4 degrees. I've measured that when I took those off, which means this tube now should be 4.1 degrees above the horizontal. And it's the big moment of truth with my inclinometer to check it. And there you go. Exactly 4.1 degrees.
Oh, no, it isn't.
Oh, yes, it is. Oh, ye of little faith. Haha, you see? You've got to believe in me. Now I can crack on with some drilling. Excellent. That's marked that up nicely. I need to take a pilot drill through there before I then open it up to the full 3/8 size. I've also got to put on this, the engine mount, and this, the fuel system mount tube. That's just a bolting exercise to make sure it fits. I'll crack on with that. Time for a break. When you come back, we'll be putting on the tail boom. Welcome back to A Chopper is Born. Imagine how heavy it was when it still had toilet paper on. I still can't believe it, but yes, I am building my own kit helicopter. It will do 115 miles an hour and it will take 2 people. At the moment, I'm about halfway through building the baby's skeleton. It's pretty much sorted, ready for dismantling, and then it'll go off for powder coating. I've put in, since you were last here, the engine mount here and also the fuel system mount tube. That all fits, so that's great. I've got to put the tail boom on, but I've got one other job to do first, which is ground wheels. But before I move on to that, I must admit to another accident on the drilling front. Yes, I managed to snap this one in half as well. I'm going to have to go back to school for a few drilling classes. Oh! A ground handling wheel for a helicopter has two basic components: a ground handle and a wheel. All I've got to do is basically drill through this axle shaft so that I can put a cotter pin through to hold the wheel on so it doesn't fall off when you're doing your ground handling. That slips on like that. So pop on the washer like so, and then the cotter pin, which will go through like that, and I just need to mark that about there. Then I need to just centre pop it, and then I get to play with another tool, the pillar drill. Sorted. So there we go, cotter pins in, and we have a fully working ground handling wheel. It's a temporary bit of kit for the helicopter, so it's a very simple piece of engineering, because basically when you want to move your helicopter around when it's finished, you have one wheel either side, slots through here like that, but you basically push down on here and hook this J pin underneath the skid. It would then be sitting on these wheels, and to move it around, all you have to do is put a little bit of pressure on the end of the tail boom, tip the front up, and then wheel it around. Only problem is, you need a tail boom, so I better fix one on. I wonder what this is for. The tail boom is made of aluminium. It's incredibly light, but very, very strong, thanks to the fact that inside here are 4 bulkheads connected by stringers. What I've got to do with this is attach it to the airframe with 3 major adjustments. One is to get it absolutely in the dead centre line of the ship, for obvious reasons. The second is to get it at the right angle to the horizontal. And the third thing is to rotate it so it's in exactly the right position to fix it to the brackets that attach it to the airframe. So, first job is to get the little end over that little notch in that wooden contraption over there. Yes, that's what it's for. Yeah, I missed one. Oops. That's all right, just check the other on this side. There and there. It's quite fiddly, I tell you. That is looking something like that. There's lots of adjustments that are required here. That's fine, that's not going anywhere. The next job is to set up my centre line that lines up with the plumb bob at the front of the airframe and the plumb bob here. The plumb bob at the front there is bang in the middle of the front of the airframe. The second plumb bob is here at the back of the airframe. What I've done is measured across the tube here and then put a mark so I know the plumb bob's hanging in exactly the middle. So that's that one. This string marks the centre line of the aircraft. But the tail boom plumb bob here is way over to the pilot side. What I need to do is simply slide the tail boom over until the bob is right over the string. And there we go. Fantastic. So that means now the centre line of the tail boom is in line with the centre line of the airframe. So the next job is to check the angle of the tail boom. The boom itself needs to be 2.5 degrees further away from horizontal than the square section tubes on the airframe. They were at 4.5 degrees, so 4.5 plus 2.5 is 7. So this needs to be 7 degrees. It is currently 7.6 degrees. I'm going to take it off, otherwise it'll fall off. And very carefully, just need to drop this down and just keep checking it. 2. Bang on, absolutely 7. But the problem is, of course, I may have moved the tail boom one side or the other, so now I have to go and check all my little plumb bobs again. It's a backwards and forwards exercise.
The basics of the helicopter, we have an engine mounted to the airframe. The engine drives the rotor system. The blades are like a wing of an airplane.